This is project 2, video number 3, the one in which we do the documentation and put the finishing touches on things, and particularly the graph in this case. Get the MATLAB fired up, get the editor going. Should have just double clicked on it, but let's open plot %me lost. Double click on it, and okay, I got to say what it does. So plot %me lost makes a graph of the percentage mechanical energy lost. I think I can do it. A wrap here, wrap comments. %me lost, and I think I'm going to move things over so that everything fits in the field of view here that I'm going to see. Yeah, that's where the line ends. Makes a graph of the percentage mechanical energy lost when an object of mass m1 collides completely inelastically with an object of mass 1 kilogram for values m1 from 0.01 to 10 kilograms. I want to check and make sure I had that right. I was going from memory when I wrote up the code there. Yeah, here it is, from 0.01 kilograms to 10 kilograms. Okay, that looks good. So plot %me loss makes a graph of the percentage mechanical energy loss when an object of mass m versus m1. So n versus m1, graph of the percentage mechanical energy loss versus m1 when an object of mass m1 collides completely inelastically with an object of mass 1 kilogram. Alright, that happens if I undo the wrap comments. Oh, that actually looks much better. Makes a graph of percent mechanical. Yeah. Oh no, I think some of it is running beyond there. No, % mechanical energy loss versus m1 when an object of mass m1 collides completely inelastically with an object of mass 1 kilogram for values of m1 initially at rest. So and I'm going to put a space in there. I want to put that down on the next line so the 10 doesn't get separated from its units. And then I go by Jeffrey Schneck. You go attribution, my attribution is no outside resources were used in the writing. This code. I thought I was going to have to look up array fun. I wasn't confident that I knew how that worked, but in the end it worked out alright. So that's supposed to be attribution. Attribution colon and then text wrap comments. Well, I guess it didn't actually go beyond the line. Alright. So no outside resources. Oh, I do have to worry about the graph. So so far no outside resources. We'll see if I have to change that. So I'm going to try title. Percent mechanical energy lost versus mass of initially moving object. That's a long title. Single quote and then close parentheses. Alright. X label mass initially object. I'm going to call that M1, mass M1. Of initially moving object, and then since I've defined that so clearly, I can say versus M1. And I think I'm going to call that M subscript 1. M subscript 1. Alright, and then I do have to put the units in there. It should be in square brackets. So kilograms, and then try a Y label. So I just change that, copied and pasted, and I just change that to a Y, and then this is percent mechanical energy lost. And that'll be expressed as a percentage, so the fact that I said percent already tells you the units. That is, it's being expressed as a percentage. So let's try saving that, and running it. So plot percent ME lost, open, close, creates a graph. Let's go ahead and move that over here where you can see it. And percent mechanical energy loss versus M1. Percent mechanical energy lost. No units, it's implied by percent that it's a percent of something. Look at how nicely I put M underscore 1 and it shows it as M sub 1. That's beautiful. Mass M1 of initially moving object in kilograms. Alright, I think the graph looks perfect. Go ahead and close that. Go back to the editor. I'm looking at this one. and I want to look at the project checklist. So no algebraic solution. I did regarding the pencil and paper part. An outline of the steps. I did that, but I don't have to do it for the project 1 part. Yeah, I didn't do anything to the project number 1 function that was working. 1 point for a reasonable attempt. I certainly did that. I got 2 M files. 1 point for a program that works properly. I think it's working. Nothing to the command window. Let's make sure it's still printing nothing to the command window. Yep, nothing to the command window. So that looks good. Then point for documentation, final touches. This is what I really need to look at here. Titled, graphs titled, axis labeled. So I only have one graph. It's titled, it's labeled. Both axes are labeled. Both what is being plotted along the axis and the units. So the units are actually in the name of what's being plotted in the one case. Let's go ahead and run that again. Up arrow, hit enter, bring it down where you can see it. So the units are, it's percent, and that's in there, and here I got the kilograms. So that looks good. What's being plotted in the units, okay. You must have your name in every .m file. I'm pretty sure I remembered to put by Jeffrey Schnick in there, okay. Your code must be documented for each function. This will include within the function itself, within the function .m file itself, a comment stating what the function does. Okay. If it takes arguments stating what argument, what each argument is, it doesn't take any arguments, and it doesn't return any return variables. So I just, of those three, I just have to say what it does. And this is what it does. My return variable, I use the word dummy to represent the return variable because that tells the reader, that word choice suggests to the reader that I'm not really using it. It's just serving as a dummy, just a position holder, because you need some return variable in the function statement. But because I'm not using it, I use that word dummy, and that implies that I'm not using it. So you never see dummy equals anything down here in the body of the code. Alright. That was an aside. For the case of a function that includes segments that are not self-explanatory, say what they do. Well, let's see if these are self-explanatory. So in here, we assume the reader knows a little bit of MATLAB. They know that I'm creating a variable that's got 100 elements, so that's cool. This is %me loss is being assigned values based on input to my get %me loss is the M1. I gave it a name that tells the reader what it's doing, so I don't have to give any further explanation on that. And then the plot command entitled the plot. So I would say there's nothing fancy in there that needs further explanation beyond the explanation provided just by the choice of my function name and the choice of my variable name over here. The same thing with M1. So you know, especially given the description of the function having an M1 in it. So I think we got that covered. We don't need any extra statements explaining it. And then you must provide attribution, and I have provided attribution. I think I got that line. Yeah, no outside resources. So I did provide the attribution. So we're, let's say, pretty much done, I guess. I think I've already run it after the last change, but just make sure I didn't do any accidental clicks on anything. Run it, get the figure up there, and yeah, I think it looks good. So that does it for project number 3. This is the end of project number 3, video number 3, and I already created a video that shows how to upload it to Sakai. You got to do I did that when I was working on project number 1 with you guys. If you have troubles, I suggest you look at that video. It does solve some of the issues that people came to me with on project number 1, but you should be able to get it up there. Keep in mind, if you absolutely cannot upload your .m file on Sakai and it's still before the deadline, Saturday at noon, then it is okay to send me the .m file as an attachment in an email message. Under those circumstances, I would accept it, but just make sure that you really can't do it via Sakai, and make sure that you send me the .m file itself. Don't just copy the contents of it and paste them into an email message. Alright, that does it for project number 2, video number 3.